All right, so today we're going to be doing some software designing. All right, I'm using this application here. It's called the diagrams.net to just go ahead and create my like a flow chart of sorts of the different softwares and the different designs that I'm going to be using with our app. So let's get started. So currently, the goal, I've actually written this in my issues. So I just go into the DailySAT app. It's in the auth.js authentication. So these are the two things we want to do. Okay, so we want to add a rate limiter and we want to add a caching system. So I'm just going to say here software design diagram for rate limiting plus caching layer. Okay, so and the reason for this is because we are fetching data from the from our MongoDB database. Um, right? Like to show in our dashboard. So if I currently go to DailySat, it's not going to work. But these like undefined and these, these empty boxes are being filled now with MongoDB data. But what I want to make sure is that the user is not abusing this data, and they're not like repeatedly using it, right? Um, that would create a lot of strain on our system. So instead, we're going to add a rate limiter. So you can only access the resource a certain amount of times, and also a caching layer. I have some good resources, some good videos. So I'm going to use this for a caching layer, and I'm actually going to not be excuse me. So there's many different ways of doing this, right? For the rate limiting, you could use many different databases to keep track of the IP address and the amount of hits. I'm actually going to be using a very non-traditional solution, you can say, and that is Dragonfly DB. It's from Israel. All right, and this is an amazing solution, right? Here's their landing page. I've read through it. It uses the Redis API, so that means that you can use like your Redis SDK and all of that. So let me just go ahead and add that as our first thing, right? So where's text? Come on, we can't get any text here. Oh, there. Okay. Just gonna make this a little tad bit bigger. Okay, so it's called Dragonfly DB, and so this is going to be our solution, our database solution. All right, because again, remember these are just in-memory databases, so they're more volatile. Like if the server crashes, all your data gets lost because it's not on the disk, it's on the memory itself. But it doesn't really matter if this data gets lost because you can just refetch it from the MongoDB again, or at worst case, the limit that the user had goes away and it'll just reset. It's not critical data that you need to worry about, right? So it's completely fine to have it in memory, but the trade-off you get from having that highly volatile data is that now you have the solution which works much more faster because it doesn't have to go through the computation of going to the disk to get the data and then bringing it back to the server, right? It can automatically just get the data because it sits on the server itself. It's in memory, it's on the server itself, so it's much more faster, and that's what we want when we're caching, right? It's to improve performance in our case, to just avoid putting more burden on our MongoDB database, right? Um, but it's also to perform to add performance, right? Because it's much more faster. Anyways, so within our Dragonfly DB, this is a Redis alternative. It uses the Redis API, by the way. So you can use your SDKs, like your Redis SDKs, the clients that you use, like within your Node.js or Next.js applications. You can use all of that. It'll still work with a Dragonfly DB server. So migrating to Dragonfly is so stupidly easy. You'd be a fool not to choose this. Look at the throughputs, right? So this is like the materials that are passed through. Um, you can see that's much more higher with a Dragonfly. It's also 25 times more performant. That's what they're saying. There's also very good, I would like to say, reviews on them, right? Companies are using them too. Ubisoft, Epic Games, these are big name companies that are using this solution. Obviously, big big companies are not going to use them right now because they're pretty new. But again, software engineering is a lot. It's a lot about trying new softwares, trying new things. I'm going to try this out. It's open source, by the way. Redis stopped being open source, which sucks. So that's another reason why. Okay, but anyways, the Dragonfly DB is going to run on a Docker instance within Oracle Cloud, Oracle VM machine. So Oracle, I should say, Cloud VM machine. Okay, I want to color this too. Actually, like, I don't know if I can do that. Oh yeah, I can. Nice. Okay, we'll keep it. We'll keep it the same color as Dragonfly. They're kind of like a purplish type of theme, so we'll use that. There we go. So yeah, so it's gonna be a Docker instance within Oracle Cloud VM machine, right? It's gonna run on Linux. So I'll say Linux OS, right? Because that's what it's usually running on, and that's what I want it to run on. Okay, so that's our Dragonfly database. Now what I'm going to do is I'm going to grab an arrow here, and I'm just gonna connect it there. There we go. So now we're gonna want our Next.js app, right? So what's gonna happen is we're actually gonna have two of these Dragonfly databases. So I'm gonna copy this. Excuse me. I'm gonna bring the same thing again over here, right? This one is gonna be used for the rate limiting because remember you need to store information about like the user about the IP address and the amount hits on a database. We're just gonna use in memory much faster. Again, it's not critical information, so it doesn't matter if we lose it in case the server does shut down, which is one of the trade-offs of using an in-memory database. But this one's going to be our rate limiter. Doesn't really matter which one, they're both the same thing. But yeah, there's going to be two instances. Again, they run on Oracle Cloud. Yeah, so let me just again, they don't have to run on Oracle Cloud, they just need to run on something. So I'll just say within a cloud. I just have some credits in Oracle Cloud, so that's why I'm using that. But I would preferably be using Amazon AWS. Just they're unmatched, especially with like not only like technically, but also like with their customer support and all that. It's amazing. Enough with the glaze. Again, it's just within a cloud VM machine, virtual machine. So we don't need machine. Let's say virtual machine. I'm just going to say VM. It's going to run on Linux OS. This one is going to be for our rate limiter, and this one will be for our caching layer. All right. I'll change the shade of this. So, so let's just go with something like that. Apply. Okay, that's great. Oh, there's a fill. Not bad. Let's go with something a little bit darker. Yeah, there we go. Yeah, so that way we can just differentiate between the two. Actually, let me just use these like predefined ones. Okay, there we go. All right, let me get another arrow going here. It'll point to the same thing, obviously. Okay, so there we go. We got our rate limiter. Actually, this will be pointing to something else. So these are going to be our routes, I guess. So what we're going to do is, if I can, oops, I keep forgetting. Let me just use A to do this. Perfect. So this is going to be our logic. And so within our logic, get user IP address. And so see what he's doing here. Okay, so the structure. So the key value pair is going to be the IP address to number of hits, right? Yeah, so as you can see, that's what's happening here. And what we will do is, okay, we'll first get number of hits. Then what we will do, then what we will do is so we've got the number of hits. We will get number of, sorry, not get number. So let me actually just bring this in here. I'm gonna probably need to make this box a bit bigger. So yeah, this is again just logic, I would say. Okay, but so the key value pair, this is like important. This is like the data modeling, right? Let's just use something like that. So yeah, so IP, a number of hits. Can I change the color? Yes, I can. Perfect. Let's go with something like that. Nice. Okay. So yeah, so we're gonna get the number of hits. Then we're gonna see if it is in limit and block if not. Before that, actually, what I want to do, check if above time limit, and then see, and then here we're gonna check. So here we'll check if it is above rate limit. So we're gonna check these two individually. So we check if it's above time limit. If so, we block. And then again, if we're gonna check above the rate limit. If so, we block. Otherwise, it goes through. If none are if none true, go ahead with request. All right. And so actually over here, we're going to have our number of hits. So I'm just going to say hits just to keep it a little bit simple. Hits and then also timestamp. So we need two things, which we'll add as like, I don't know. I have to see how we can do that. Yeah, I'll look into that right now. But yeah, right now, so what we need is our IP as our key, and then our value. Our value will be hits, so the number of hits and the timestamp. And so if none, go ahead with the request. And then we also want to obviously increment it. So I'm going to say and increment hits by 1. So that's the sort of logic we will go for. So let me just make this a little bit higher. And let me give it a space in between, like that. And let's actually bring this a bit down. Okay, there we go. Okay, so that's the logic, bare bones logic, right? You have your key value pair. It's going to be the IP, the hits, and the timestamp. We get the number of hits. Check if it's above time limit. Check if it's above the rate limit. And if none of these are true, we go ahead with the request, but we increment the hits by 1. Let's see what they're doing here. By the way, this is Dragonfly. He's using a Dragonfly server. It's just that, again, as I said, it's using the Redis API. So that's why it says Redis client, because he's using the Redis client, but with a Dragonfly server. Just so that, we're a little bit clear. Oh, oh. I'm a little bit, yeah. Okay, so we can keep this as hits. I just realized. So we can keep this as hits. So I'll say number, or I'll just type it up. Why not? Number of hits. Um, So here what I'm going to say is if key value pair does not exist, create one. Hmm. Okay, okay. Yeah, so create one with one hits, and then check if it's above not true. Continue, 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 continue with request plus increment, increment, increment hits, and add a new expiry of for 60 seconds. So, or this is a little weird. I'm not quite sure if I get this. So continue request plus increment hits and add a new query, and that's for 60 seconds. So get number of. Okay, so I understand this, but then this part is a little weird. I'm not fully sure how we're gonna do that. The caching layer is gonna be very simple logic, so we don't need to worry about that really that much. Not true. Continue with request plus increment hits. Increment or decrement? Okay, so here we're saying that if it's over or equal to 4, so if it's yeah, so if it's basically equal to 4, then the rate limit has exceeded. Retry after a minute. Oh, right, and it'll stay active for that time. So actually, what we need to do is uh increment hits by 1 hits and have an expiry of, let's say, I'm gonna do 5 minutes. That's 300 seconds. So this key value pair will exist for 5 minutes, and since so here, every time we keep trying, we're gonna see the current try, and if the current try, right, which it will just keep incrementing. So, uh, so increment the current key value pair regardless of uh regardless of anything, I can say like that. So okay, perfect. So get number of hits, right? So or I should just say get key value pair. And if it doesn't exist, create one with one hits because you hit it one time, you hit the API with one time, and then since remember I keep forgetting this is Redis is still using Redis principles, so you do have that expiry option. So this key value pair will have an expiry option. You can put it as whatever, it's in seconds, but I did 5 minutes, which is 300 seconds. Now if we check, so this again is just like an if. It's an if, so I'm just gonna actually change that color there. Let's apply. Perfect. So now we're gonna check if it's above the rate limit. So if it's above the rate limit, all right. So 429. 429 code just means you've overused this resource. So, but yeah, so if it's not true, then continue with the request. Otherwise, so I'm just gonna do like this. So otherwise, block with 429 code, and then you're gonna increment the key value pair regardless of anything. So this way, let's say if I have a maximum of, let's say, 3 hits, right, in 5 minutes, what I'm gonna do is I'm gonna hit it one time. Okay, so let's say this is my first time going into this this server, right? So boom, I hit it one time, so I get a key value pair. It doesn't exist, so I create one. As that one hit, I have the 5 minute expiration time. It's below the 3 hits because one is less than three. So we continue with the request and we increment it. So now it's at 2 hits. Our IP, let's say our IP is one, right? Again, it's hypothetical. If it's one, so now one. So this is how our key value pair would look like: one, two. Sorry, one. So actually, this should be at 0 hits. My bad. So again, this is why I like to walk through my logic. So let me try this again. So again, I'm an IP of one. So so we create that, right? So if we create one with, yeah. So sorry, let me just redo this. Okay, so let's redo this logic. Let's go through this logic again. Again, this is why this is reiterative. We're just kind of looking and seeing if this kind of works, if the system works. Okay, so again, what's going to happen is I request, I'm IP address one. So what's going to happen is I'm going to get a key value pair. Mine does not exist, so this statement is true. I create one. It checks, the system checks for my IP address. Let's say our IP address is one. Again, that's not possible, but it's just hypothetical. Our IP address is one, and it's going to create it with 0 hits. So this is how our key value pair looks like now. Now, if it checks if we are above the rate limit, we are not above the, or actually, this should start with one. My bad. Yes. Okay. Okay, let's restart this. My bad. Uh sorry. Okay, again, this is my first time hitting this API. Boom, I hit it. So we get the key value pair, doesn't exist. So we check if the key value pair does not exist. That's true. So we create one. Again, it goes, checks for my IP address, gets my IP address, because that's uniquely identifiable to your specific, um your specific, sorry, I'm having brain fart, your specific computer. So you have that, let's say mine's is one, not possible, but again, it's hypothetical, we don't care. And then the amount of hits we start off is with one, and then we have an expiry, so I'll just use ex of 300. So now what we're going to do is we're going to check if this a number of hits is above the rate limit. I set my hypothetical at three. So 3 requests per 5 minutes or per 300 seconds. And it is below that, right? So therefore, we're good, right? So it's not true means it's below limit. And so therefore we can continue with the request because one is less than three. And so we continue with the request. I get my, I don't know, cat images, whatever. Otherwise we block, we don't need to worry about that. Okay, now we increment the current key value pair to 2. And let's say it's like, I don't know, we're pretty fast with it. Let's say it's 250 seconds are remaining. Okay, so expiry in 250 seconds. Okay, so again, we'll go back here. We'll get our key value pair. We got it. We don't need to do this again. We're good. Then what we're going to do is we're going to check if it's above the rate limit. 2 number of hits is not above the rate limit, excuse me. So it's below the limit. Therefore, we can continue with the request. We give another cat image. Now we increment it again. So now we're at 3. So if the key value pair, so again, we'll get the key value pair. Sorry, we'll get the key value pair. So we got this. Let's say it is 200 seconds now until this expires. We're good to go. We don't need to worry about this. We check if it's above the rate limit. It is not above the rate limit. It's at the rate limit, so we'll allow it, right? Because our rate limit is 3 request, and we have 3 hits currently, so we'll allow it this time. Okay, now again we're gonna continue with the request. We'll give a third cat image. All right, and we're gonna increment this again. And this is the importance of this. We're going to increment this again. Okay, regardless of anything, we're incrementing it again. Now we're going to go back and get the key value pair. Again, it's this. Let's say I have 150 until expiry. We're gonna, it exists, so we don't need to worry about this. And then we check if it's above the rate limit. It is. 4 is above 3. So therefore, this time, finally, we're at the otherwise section where we're gonna block this request with a 429 code. So we're not gonna request any other external servers that we might have, like maybe a CDN, to get that cat image. Instead, we're gonna give maybe a JSON response, depending on your architecture and whatnot. We're gonna give a 429. This is HTTP code, excuse me, which means that you've exceeded your or you've exploited the. I'm oversimplifying this, but you've exploited this app, excuse me, so you can't use this anymore. All right, so that's what we're going to do. We're going to block it with the 429 code, and then again we're going to increment it. Okay, so now we're at 5. Now again, this is we're going in a time-based format. So let's say now it's like 90 seconds left. If you go through this whole logic again, it'll still block it, even though, like, because you've exceeded the amount of hits, and also because the key value pair still exists, right? But then after that 300 seconds, so let's say we're at 0 now for expiry, the Redis will, or in this case Dragonfly DB, will automatically delete that instance. Okay, it'll automatically delete that key value pair. So now what's going to happen is when you go to get that key value pair again, after the 300 seconds are up, it will create a new key value pair with a newly, freshly reset 5 limit time period. So then for the next 5 minutes, you'll have that key value pair which exists, right? And then eventually that will also delete itself, and then you have to create a new key value pair. So that's how the logic works. It's not too complicated, right? But that should work for us right now. Again, we're gonna probably later on in our time, we're probably gonna have a distributed system going on. So like, let me just move this a little bit down there. It's a lot of space. Um, so that you basically have like horizontal scaling going on, and load balancers. But again, I don't really need to worry about that right now. I don't want to put a lot of software into my app, right? And then overwhelm it, right? Because then you're gonna have a lot of bills to pay, right? So that's another thing about software engineering. You want to make sure that you're being economically conscious, right, of the services you're building. Okay, now for the caching layer. So I'll, just for the fun of it, why not? I'll also have this going both ways. Okay, we'll keep it like that. So basically you have it 2 ways. Okay, let me bring this down here. Because again, this does require bilateral communication. You're sending data both ways, right? From the Dragonfly DBs of the 2 instances that we've created. So this one's got a little bit more easier. It's pretty not easier. It's pretty simple. Sorry, that is easier. I'm tweaking out. Okay. Anyways, again, same thing. So let me just get this key value pair. In this case, it's going to be a little different. So the key is going to be the date type of data, and then the value is just going to be string JSON. So just stringified JSON. All right. So you have your type of data. So I'll actually give some examples so it just makes it more clear. Examples. Again, I want black. Actually, that's kind of tough. I'll keep that. Okay, examples include like user data, email, test@gmail.com. Something like that, right? Or let's say I don't know, previous question 2 plus 2 plus 2 answer 4. And obviously this is not perfectly stringified because we needed to add these, and then we have to add these like that. There we go. It's just formatting stuff. Oops. All right. I'll keep this actually as a number. Nice. Okay. So there are some examples for maybe developers who are a little bit clueless on what's happening, right? So you have your type of data and then your string, which is in JSON. So the main use case and the way it kind of relates with the rate limiter, I'll actually kind of give a little bit of a textual representation of that here, right? So user data will be cached when rate limits so for me I'm gonna only allow one request in each of those 300 seconds. So yeah, it's pretty long, but anyways, so user data will be cached when rate limit has been reached to ensure dashboard is populated. So there we go. So this is two parts of the same app. So I'm going to create like a little like umbrella like under this, right? So it's two parts of the same app. So let me put this backwards, or actually let's send it forward to front. There we go. Yeah. Okay, so this is actually interesting. I can't stretch this out. Okay. Oh wow, they have errors already. There we go. Nice. But again, this is a lightly concerning. There we go. Okay, there we go. So this is just me being a little bit obsessed. Let me just make a new thing here. Send to the back like so, and there we go. Okay, so it's the same app. So let me actually add some text so that people know this. So this is DailySAT web app, right? and then db uh, instances. That's this one bit. Okay, so I'll actually have a thing for here too. To the to the back, and then this to the back too. And then let's have a nice color here. Keep everything nice and colorful, right? Just use different popping colors here. That's not very popping. That looks very cheap. Uh, okay, let me make this. There we go. Okay, and this is gonna be let me add like a text here. So let's bring this a little up. I'm just gonna say rate limiting plus caching design. And so this is gonna be definitely bold, and let's give this like 30. It's like the main header, right? Okay, let's use a different color here. Yeah. Or actually, let's give this this color, and then let's give this that color. Perfect. Okay, we are done. There we go. Yeah, again, as I said, I kind of give you a brief overview of everything. Again, the reason why I picked Dragonfly is because it's much more performant than Redis, right? And it's actually much more cheaper too, because it's more smart with resource allocation, which will use less of the services that you need. So yeah, that's the reason why I did that. And here is my software design.